What if I told you that the entire AI revolution, every stunning image, every line of human-like text from ChatGPT, every major scientific breakthrough rests on the shoulders of one company? It's not Google. It's not Microsoft or Apple. It's a company that, for decades, was known primarily for making video games look prettier. This is the story of how Nvidia, a company that started out in the niche world of 3D graphics, placed a quiet, decade-long bet on a technology nobody else was taking seriously. It's a story of a genius strategy that didn't just anticipate the future, but built the very tools that would define it. This is how Nvidia became the undisputed kingmaker of the artificial intelligence era. The year is 1993. Three engineers, including the now iconic Jensen Huang, meet at a Denny's restaurant in Silicon Valley. Their idea is simple but ambitious: create specialized computer chips that can handle the complex geometry and pixel-heavy calculations needed for 3D video games. They call these chips graphics processing units, or GPUs. Their early years were a brutal fight for survival in the hyper-competitive graphics card market. They battled rivals like 3DFX and ATI, winning by relentlessly pushing the boundaries of performance. Their GeForce 256, released in 1999, was marketed as the world's first GPU, and it cemented their position as a leader in the PC gaming world. For years, this was Nvidia's identity. They were the engine behind realistic shadows, lifelike water, and explosive special effects in the world's most popular games. They were making billions, dominating their niche, and to the outside world, that seemed to be the endgame. But inside the company, a quiet revolution was brewing. Jensen Huang and his engineers noticed something fascinating. Their GPUs were designed to perform thousands of simple, parallel calculations at the same time to render a 3D scene. This was fundamentally different from a CPU, or central processing unit, which typically handles a few complex tasks sequentially. They realized this parallel processing power could be used for more than just games. It could be a supercomputer on a chip. This realization led to the single most important decision in Nvidia's history. In 2006, they released CUDA. CUDA was a software platform that acted as a key, unlocking the massive parallel processing power of their GPUs for general-purpose computing. For the first time, developers and scientists could easily program an Nvidia GPU to solve complex problems in fields like medical imaging and climate science. Most of the world didn't notice. The gaming community didn't care. Wall Street barely registered it. But Nvidia had just laid the foundation stone for its future empire. They were no longer just a graphics company, they were a parallel computing company. By the early 2010s, Nvidia was at the peak of its gaming dominance. They were the brand every serious PC gamer wanted. But the omen of their future wasn't a threat, it was a tiny, academic field of computer science called machine learning. A small group of AI researchers had discovered that training their neural networks, a process that required millions of repetitive calculations, was excruciatingly slow on traditional CPUs. It could take months. But on a high-end Nvidia gaming GPU, thanks to CUDA, they could do it in days. They were using gaming hardware for groundbreaking science. Then came the big bang moment for AI. In 2012, a neural network called AlexNet shattered records at a major image recognition competition. It was more accurate than any previous system by a massive margin. The secret to its success? It was trained on two Nvidia GeForce GTX 580s, graphics cards you could buy at any computer store. This was the signal. This was the proof of concept that Jensen Huang had been waiting for. While other tech giants saw AI as a distant, software-focused problem, Jensen Huang saw it as a hardware problem, a problem his company was uniquely positioned to solve. This was Nvidia's stroke of genius. They went all in on AI before it was a buzzword. They bet the company on this emerging field. They didn't just keep selling their gaming cards. They began a decade-long crusade to build an entire ecosystem around AI development. They designed specialized chips with tensor cores built specifically for the math used in deep learning. They developed entire libraries of software, like CUDA, that made it even easier for developers to build and train AI models. They poured billions of dollars into research and development, creating a flywheel effect. Better hardware enabled bigger AI models, which in turn created more demand for even better hardware. Nvidia wasn't just selling the shovels in the AI gold rush. They were designing the shovels, building the railroads to the mines, and writing the laws of the new frontier. Their competitors, like Intel and AMD, were focused on the massive CPU market. They saw AI as a niche, a distraction. They completely missed the architectural shift that was happening right under their noses. By the time they realized their mistake, Nvidia was already a decade ahead. And then, in late 2022, the world changed. OpenAI released ChatGPT. Suddenly, generative AI was no longer a theoretical concept. It was a global phenomenon. Millions of people were interacting with it, and every major corporation on the planet realized they needed an AI strategy immediately. And to execute that strategy, they all needed one thing: thousands upon thousands of high-performance GPUs. There was only one company that could provide them at scale: Nvidia. The fallout was an explosion. Nvidia's revenue and stock price skyrocketed. They became a trillion-dollar company. Tech giants like Microsoft, Meta, and Google began spending tens of billions of dollars a year, not on building their own data centers, but on buying Nvidia's DGX systems. Nvidia now controls over 90% of the market for AI training chips. They have a moat so deep and wide, built on years of hardware innovation and, more importantly, a locked-in software ecosystem that competitors are struggling to even get a foothold. They are the new OPEC, but for the resource that powers the 21st century: computation. The story of Nvidia's rise from a gaming company to the heart of the AI revolution offers powerful, actionable lessons. First, build the ecosystem, not just the product. Nvidia won not just because its chips were fast, but because CUDA made them usable. Their software created a deep, defensible moat that locked in developers and made switching to a competitor incredibly difficult and expensive. The product gets you in the game, the ecosystem lets you win it. Second, anticipate where the future is going. Jensen Huang saw the potential of GPU-accelerated computing for AI a full decade before the market exploded. He had the vision and courage to invest billions in a niche that others ignored. True innovation isn't about following trends, it's about creating them. And finally, create your own market. Nvidia didn't just enter the AI hardware market, their tools and platforms fundamentally enabled its creation. By making parallel computing accessible, they empowered the very researchers who would go on to invent the technology that now drives demand for their products. They built the kingdom, and now they collect the taxes. Nvidia's journey is a masterclass in long-term strategy. It's a reminder that the most profound technological shifts are often born in unexpected places, and that the companies who win are the ones who build the fundamental platforms upon which the future is built. If you found this case file valuable, hit the like button and subscribe to Corporate Case Files for more deep dives into the strategies that shape our world. And now, I want to hear from you. Comment below: what company do you think has a realistic chance of challenging Nvidia's AI dominance in the future?